Cast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and thank you for joining us on our call today. My name is Nicole Van Wert-Quincy from Transcat, and I'll be your moderator this afternoon. Our webinar topic is using acoustic imaging to detect compressed gas leaks. The topic is being presented by Adam St. Clair and Michael Stewart from Fluke Corporation. Adam has been with Fluke for 8 years in several different roles, from the factory to the field. He's currently part of the Industrial Imaging Business Unit, working to launch new industrial imaging technology into the industrial space. Michael is a practicing IRT Level 3 thermographer and has significant experience in the use of thermography for electrical, mechanical, and building inspection applications and analysis. Most recently, he served as the program manager and application specialist for Fluke's new acoustic industrial imaging technology, and he continues to support the development of new applications for that technology. We expect the presentation today to last roughly 30 to 40 minutes, and then at the end, we'll open it up for questions and answers. During any time during the presentation, you can send questions through the question box, which is in the webinar controls on the right side of your screen. I also want to mention that the webinar is being recorded. You will each receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. So at this time, I'm going to turn the presentation over to Adam and Michael.
All right, thanks, Nicole. Are you seeing our screen already, or do we need to get a request and accept that?
I think, yep, you're right. Hold on a second. My apologies.
All right, that should do it. Looks like we're live on this here.
Perfect. Yep, I can see you.
All right. Well, thanks for everyone for joining. We're excited to take a little bit of time to talk about not only the tool and the applications, but also why it's important and how it can help the different workflows within the environments that a lot of you are in. So Michael was a big part of not only developing this technology, but also helping customers understand the different applications and ways to use this as a tool to be a significant contributor to cost savings and downtime. So we're going to jump around a little bit on those three topics: the tool, how to use it, why it's impactful, and then spend a bulk of our time understanding some of the different applications that we've been successful in. So with that, I'll turn it over to Michael, and I think we're going to start by really understanding how this is different from ways that people have used technology in the past to identify and fix compressed air leaks.
Thanks, Adam, and thanks, Nicole. I'm glad to be back again. I haven't done one of these webinars for Transcat and its customers in a number of years. Used to do them on thermography, and I'm a little bit of a techie, and I'm definitely a field guy. I like going out and doing the work with all of you guys, trying to solve real-world problems. And the last couple of years, I've been in the technology development group here at Fluke, and we noticed that there's a lot of low-hanging fruit that's still out there on our quest to be more energy efficient in our factories and our commercial facilities, our buildings. And we've been listening, and this brought us down a route to explore how do we visualize sound and ultrasound. Specifically, sound and ultrasound that's generated by compressed air or compressed gas leaks. And, I think the really important thing for everybody to understand before we start in the slides is why you should care. You go around and you talk to these people, and sometimes you're walking around in a factory and you hear a slight hiss, but you're not really sure where it's coming from. You say, it's just an air leak on one of the compressed air tools. It's no big deal. Well, it turns out it is a big deal, and it's a big deal for a number of reasons. If compressed air or compressed gases are important to your facility, that could affect the performance of the equipment. If it's a handheld tool or something like that that controls a torque on manufacturing or a process line, that's really important. If that doesn't have the right pressure going to it, it can have a performance problem. But the bigger picture of it is somewhere in that facility, there's a compressor that's using a whole lot of electric power to actually keep the system pressurized and keep everything running. And if you've got a whole bunch of losses somewhere down the line, even if they're a whole bunch of small losses, they add up to almost a big, like a 4-inch pipe worth of air that's just leaking out. And it causes that compressor to continue cycling and continue running, continue using more power. And we don't think about that from a day-to-day standpoint, but trust me, somebody that's paying the power bill on that plant, they're actually seeing the electric bills and seeing the effect of those compressors running again and again and again just to keep things at a nominal level. So beyond the compressed air, if you're a process facility that has different kinds of compressed gases, guess what? It costs you money to purchase those gases or to manufacture those gases if you're in manufacturing. And if you're leaking all of your product back out into the atmosphere, you're losing production dollars, you're losing money. So the reason why you should care about this kind of product and this kind of technology is it helps you easily identify and document where these losses are occurring, whether it's compressed air, it's argon, it's nitrogen, it's anything else that you've got on there. If you're leaking it out and it's important to you, you need to know where to actually go to try to fix it. And sometimes, like you're getting to be my age, you're not hearing that hiss quite as much as you used to when you were younger. And it's really difficult to document that you've heard that hiss, or you feel it and then tell the guys upstream, hey, we need to go and do some maintenance on this equipment because we're losing air or losing gas or whatever else. So that's sort of the problem that we were trying to solve in the technology development group, is how do you actually see these things and document them? And as I said, I sort of came from a thermography background, so I was used to that visible image, and I understand that picture is worth 1,000 words. The infrared picture is worth 10,000 words. The acoustic picture is worth 10,000 words. So we've already gone out, and from the very beginning, we started testing this technology all the way up to the current point where it's a real product, the i900, and we have proven this again and again in different plants, that it does in fact save time, it saves money, it saves effort, it saves headache. So whatever your hot button is, this is why you should care about this. So, and if you got other questions later on that kind of stuff, I can talk to you. There's also case studies that are now available from Fluke, and I'm sure Transcat will have those available very soon, maybe to send out to you guys if you'd like to read up about what we've done. But with that being said, let's go ahead and start off the presentation. So what is acoustic sound imaging? All right, I want to say that right now, keep in mind that acoustic, when we use that term for Fluke and for the i900, includes both the sounds you can hear, the sonic sounds, and the ultrasonic sounds, the things above human hearing. And we've developed a technique in order to listen for those sounds with an array of specialized microphones and then process them so we can create an image of where that sound is coming from, based on the frequency of the sound and the decibel level of the sound, how loud it is. And I'll tell you what, even though our ears might not be able to hear them, leaks create a particular kind of sound. And we can pick it up, and we can visualize it, and we can localize it. And it's pretty neat stuff. We take that, and then we take a visible light camera, we blend them together, almost like what we did on the infrared side at Fluke many years ago with IR fusion. This is like an acoustic fusion where you have that image of the sound and where it's coming from over a visible light. Pretty cool, huh? Okay, so some of you are saying, oh yeah, I know about acoustics because I've been practicing ultrasonic specialist for years, and we've used ultrasonics to find it for many years. This is not new technology. Well, it's a little different. As I said, we're dealing with sonic and ultrasonic, and we're dealing with a broad spectrum. Okay, we're not just dealing with 48 kilohertz or 43 kilohertz or 34 kilohertz, which a lot of the ultrasonic tools do. All right. You don't actually have to physically listen to a heterodyne or sort of a translation of that unheard ultrasonic sound into a sonic sound so you can listen for the hiss. You don't actually have to look for numbers bouncing up and down on a little tiny screen. The other nice thing about it is you don't have to do this wand scanning motion. All right, it can be very, very time consuming to use traditional ultrasonic tools often to find air leaks in very noisy, very large environments. You get a lot of reflections, you got a lot of other things going on, you got to sort of aim where you're putting the tool. It can be challenging. It can be really challenging. And with ultrasonics in particular, those ultrasonic sound waves don't typically travel very far in the air from the point source. That's another reason why we decided let's do ultrasonic and sonic. And let's give all of you guys the opportunity to sort of look for where the best place to look for a particular kind of leak might be. And it also gives us the opportunity to give you an image of where the leaks are occurring. So rather than just pointing to something and saying, hey, let me put an air leak tag on this, saying this is where it is, still a great idea, by the way. You can also document it with an image or a video of where it is. That really helps for finding the leaks again later on. So we've done a lot of work on this, a lot of field time already, both with our prototype units and with the i900. And, you know, we're able to find multiple leaks at the same time and document them. That's something that you really can't do with traditional ultrasonic tools. And it allows you to really, you know, a lot of people call finding leaks going on a snake hunt. You listen for the hiss. Well, guess what? You can have a whole lot of snakes in one piece of equipment, and it's really difficult to discern that with a traditional ultrasonic tool unless you follow every single line and every single junction and connection. With the i900, you can do it all at once. Okay, so a lot of the things that we've learned along the way. You know, sound is interesting. Okay, I can always hear my sons creating a mess downstairs, even though I don't have direct line of sight to them talking and laughing with their buddies and breaking things and stuff like that. That's because that sound travels through the airwaves. It gets reflected off of the walls. It also gets diffracted, and it goes around the walls, around the edges. All right, so we can. This is a good thing and a bad thing when it comes to an ultrasonic and sonic imaging device. We have to be aware of it and sort of say, I see a reflection off of the floor, the concrete floor. My brain tells me that concrete floor is not producing sound, so it must be a reflection from somewhere else. So that's good. We ignore the obvious things that are false positives. But then we can also use that reflection and that diffraction to try to find the images. It's almost like, hey, I have a clue. I'm going to follow the trail that that clue gave me and find out the exact location of the air leak. When you're using traditional ultrasonic tools, you're going to see all of those ultrasonic reflections as well on the floor, but you gotta, it can be a lot more challenging because you don't have a visible image of exactly where it's coming from. Okay, this is exactly what I'm talking about. Looking at the floor, A, B, and C. If you look at C, you're not seeing an actual line right there. You're seeing the floor. A and B, you know, I was actually there when we did this. This was a workstation at one of our sister companies, and I looked down, and my first thought when I looked at A was, hey, oh, there's a leak on that airline for that tool. When I moved a little bit to my right, and then further my right, I realized it's not coming from that airline. you have to be able to walk around and look at it a little bit from different places. When I realized by C that it was a reflection, I sort of looked straight down on it and saying, if I look back up from that point on the floor, I should be able to find the actual air leak. So D actually shows me starting to bend down and look underneath the work table, and sure enough, E and F, I'm actually able to see that the actual leak was below my eye level, below the imager level, under the table. Doing this with a traditional ultrasonic tool takes a lot of time. With this, it becomes a no-brainer. It is really, really simple. So you got to be able to move a little bit to figure out if you have a reflection or the sound's coming from somewhere else. Here's a video of the same thing. And we've done this again and again and again. So don't be afraid of reflections. If you see something that you're pretty sure is a reflection, you can use it as a clue to find out where the actual leak's coming from. You can get false echoes too. It's going to bounce around. You're going to get some noise. But when you're using this imager, notice that almost all the noise points to where the real problem is. With the way that that array is designed, the problem is going to become obvious. And you can use that noise and use those echoes, those what they call as lobe reflections or lobe echoes, to point to the real problem. And air leaks, unless they're very intermittent fluttering air leaks, they're a pretty constant source, and they give you a very, very bright spot that you can go after. This was an interesting one. This was that same sister company. I can remember looking up at a piece of equipment and saying, wow, I wonder if that sound's coming from inside the equipment through the door. When I started moving around a little bit more, I found out that it was actually, it seemed to be coming from a solid surface. So I'm like, that doesn't make any sense. So I looked behind me and looked up above me to make sure it wasn't a reflection. It wasn't a reflection. So I said, I wonder if this is coming from up above and leaking over the top of the equipment. So we got a ladder, we stepped up a little bit, and sure enough, we found the leak on the top of the equipment. And once again, I'd like to see you do this and do it in the amount of time that we did with the acoustic imaging tool if you had a traditional ultrasonic device, or you were just trying to listen to the hiss with your ears. This was one of those kind of leaks that we could not hear. This was full production time in this particular factory. There are plenty of other noises out there, and we were able to find this one and pull it out from everything else that's going on. That's the other nice thing about this technology is you can tune the frequency and ignore a vast majority of the other things that are going on. You don't have to wait for the quiet Saturday morning and spend extra money for weekend hours to have somebody going on a snake hunt and finding air leaks or finding gas leaks because all the production's shut down. You do this right in the middle of production. Okay, so air leaks are a complex thing. They're not going to be at just one frequency. All right, that's where there's a real disadvantage with traditional ultrasonic tools because they will typically only sample at a particular frequency. All sounds, including air leaks and gas leaks, have a complex signature or sound signature, which is what we're here. It's frequency versus loudness or sound pressure level. So what our product allows you to do is take a couple of unique peaks and unique spikes and be able to focus in on those. And a lot of folks out there, they've had a really, really good luck in the 30 to 40 kilohertz range, 30 to 35 kilohertz for air leaks. Depending on the situation, sometimes I've also had really good luck in the 17 to 25 kilohertz range, which gives a little bit of the stuff we can hear and a little bit of the ultrasonic as well. It really depends on the situation, but this is always a good starting point for you. Okay, we talked a little bit about this. If you look for peaks, you look for humps in that spectrum chart that's on the product, you can actually ignore everything else. Ignore the other loud sounds and the machine noise that frequently makes us have to wear earplugs. All right, so very, very easy to do with the touch of the finger. You can actually select your frequency filtering and select the right thing for the kind of leak that you want. If for some reason you're pretty sure there's a leak there and you're getting a slight signal, but you're not getting great signal, move that frequency band up and down just a little bit and see if you can get a better picture. All right. The more we do this, the more we find interesting places and obvious places that there are going to be air leaks. This can really help your inspections when you're doing compressed air leak inspections. Anywhere that you've got a drop down from your main ring or your main feed lines onto a production floor, look at any connection point. Inspect the entire length of the hose. Basically look at where the tools connect to the drop downs, or the drop downs connect to the equipment that's actually utilizing the compressed air. You'll be surprised at what you find. A lot of low-hanging fruit to find there. Any kind of connections you can think of, whether they're push connections, they're quick connects. By the way, those quick connects are notoriously for having bad seals, because the idea is they plug them in and out all day long and swap tools and things like that, and the stuff just wears out over time, and especially if you have really inexpensive ones. Things like this is a simple push connect for a tube. This could be a frayed tube end. This also could be the actual connect itself that has some bad barbs in it. It's just not grabbing good enough. Either way, it's just sitting there leaking air.
It's probably pretty loud there right next to the compressor, wouldn't you say, Michael?
It's very, very loud, yeah.
Is that what we're picking up?
And if you look at all that stuff below 25 kilohertz, you look going up and down is your frequency, and going left and right is your decibel level or your loudness. There's a lot of machine noise going on right there. But you're able to pick up that minute air leak on that small tube with all that equipment running. Same kind of things here. You find these regulators having problems on a regular basis too, because they're subject to a lot of vibration. People don't think that that's a consumable part that needs to be swapped out every now and then, but we find leaks on the O-rings and the seals of these things all the time. We find leaks on the back of the gauges, any number of things. Anywhere there's a potential connection there, you can have some kind of failure. These regulators are notoriously bad. Discharge valves. Now, interesting things. You're going to know by the kind of facility that you have whether something is a specific device that's meant to be discharging on a regular basis, or it's not meant to be. If it's a normal exhaust, of course it's going to be blowing off air, blowing off some kind of gas. But sometimes you can sit there and you can actually watch the cycling of the device too to make sure it's working properly. If it's supposed to go on a certain pattern and it's going all the time, that's a problem. You name it. It doesn't matter. Plenty of stuff going on in this production facility. A lot of canned beverages going by, and so there's a lot of noise, there's a lot of hissing, there's a lot of rumbling. We're still be able to pick up the air leak up underneath the table. And you don't have to be right up on it either. Boiler tubes. If you don't have your air-fuel mixture proper on your boilers, it's not going to be running real efficiently. So understanding whether or not you're leaking air into the system, that's a real good thing to know. And once again, look on this. This is in a slightly different range than what was originally recommended. All right, this is giving you a little bit of the stuff right down in the high sonic and then the low ultrasonic. Okay, this is once again saying it's not just about compressed air. It doesn't matter what the gas is that's compressed. If it's leaking out, it's probably going to be making some kind of sound, and you can pick this up. So this was a leak in a valve at a steel mill, you know, pretty decent sized leak too. And this is beyond just a loss of production capacity. This becomes a safety issue as well. You don't want to have natural gas leaking out, especially into confined spaces. I won't mention the large automaker that I visited last summer, but we were able to find a significant natural gas line leak, and it was on a welded brazed connection on a very large pipe, and we were able to see it from about 60 feet away, way up in the ceiling. And it was enough for them to go up on the mezzanine, take a closer look, take a look at a sniffer. I mean, they recognized right away. I thought it was a big compressed air leak. We went and looked at it, because we don't have any compressed air lines there. That's a natural gas line. We got up on the mezzanine. We looked a little bit closer. They actually got a sniffer out too and looked at it. And sure enough, it was up there accumulating methane up on the top of the building, which could have been catastrophic. So that was a good find that day. It's not always about the manufacturing systems. Sometimes it's the actual products themselves. We went and visited, actually been to a couple of different facilities that manufacture large semi-trucks. And they've got a lot of compressed air lines and pneumatics that help run the trucks themselves and various aspects of the trucks, including the braking systems. So when you have leaks in those kind of systems, you're going to have performance problems, and they don't want their customers having problems with the product that they're selling. And this isn't just semi-trucks. This can be any kind of production testing on a product that uses compressed air, compressed pneumatics of any kind. A lot of these folks, you know, they will have liquid pneumatics on their products. Well, before they leave the actual production facility, they're put into service, and before they put the liquids and pneumatic oil in, they typically will test them with compressed air, just to see if they have any leaks before they waste the fluids. So that's something you should be talking to customers about as well. Find out if they have a product that uses pneumatics. Going back, here's a nitrogen leak. Guess what? Somebody's paying a company for tank loads of nitrogen. All right, and what are they doing? They're just leaking it off into the air, leaking off into the atmosphere. We found similar leaks on oxygen tanks, argon CO2 welding gas tanks. We've even found them at the facilities that manufacture the gases and compress and refrigerate the gases, you know, as part of their product. All right, and so it's really important to be able to see this stuff. It will not tell you what gas is leaking. It will just tell you there is a sound that is apparently similar to some kind of leak. It's up to you guys to know what you're looking at. Ammonia, something else. That can be an expensive gas too. All right, a lot of refrigeration systems out there. I don't care if it's ammonia, it's a new 143 refrigerant. That stuff costs money. All right, and if you've got it leaking out of your system, not only are you going to have performance problems, but down the road, you're going to have to be paying more money to have it filled back up again. Here's a nice argon leak. Argon's a particularly expensive gas. Okay, so there's a lot of other applications too that really don't have to do with compressed air, but have to do with moving air or a gas from one place to another. This is actually a duct leak at a coal plant. We've actually found things with just HVAC systems in some cases too. Things that are very difficult to find and that could cause problems. And it's not just about pressurized things. Sometimes it's about vacuum lines as well. You know, so look at your facilities and your customers that have vacuum systems as well. Think about the big vacuum systems that pick up large pieces of steel and move steel plates. If any one of those vacuum suction cups is not working properly, you could drop that steel plate and halt your process. If you've got a vacuum system that takes out debris from a laser cutting system and something is not working on that and it's not pulling the debris out properly, you could have quality issues. So think about this a little bit differently. Think about any kind of compressed air, compressed gas, or vacuum leak that might either cost money or cost quality or performance issues. And that's where you're looking when you're walking around. If you're hearing hissing when you walk somewhere, you've got something. How are you actually looking for that now? Are you using traditional ultrasonic tools, taking a lot of time and money and training doing it? Are you trying to do it with just your ears? Are you using, soapy water in a spray bottle and looking for the bubbles coming up? What are you doing? And think about how much time and effort it takes you to do this and when you have to do it. And, our thought, at least here at Fluke and Transcat, is you'd be a lot better off with a product like this that makes it very, very easy to find these kind of problems, tag them, fix them, double check them, make sure you actually fix the right thing, and do it on your own time when you want.
All right, that's all we got for the application shots there. Nicole, I know that you were working on gathering questions. Has there been any questions from the group thus far?
Yeah, we do have several questions from the group. Let me pull them up here. Let's see. Yeah, we have several. Okay, what about vacuum leaks such as I'm going to mispronounce this, lyophilization equipment? There we go.
Light optimization equipment, is that correct?
Lyophilization equipment, which I think it's like the process of freezing.
Okay. Okay. A lot of it is going to depend. It's going to depend on how big the leak is. Vacuum leaks, because the sound is actually, sound's traveling through air, it's going to create a sound on both sides of the leak, but a majority of the sound will go inside the line. So with vacuum leaks, it really depends on how much vacuum are you doing. Like I don't know if I've actually tested that particular kind of equipment. I have tested things like flour delivery systems in a large commercial bakery. Things like that, we're able to see it. I don't have a particular number for the smallest vacuum leak you can detect. What I recommend is talking to somebody there at Transcat, getting a demo, going out on site where you have a known vacuum leak and testing it out and seeing if it works in your particular environment. Because those environmental noises make a big difference when it talks about really, really small things.
Okay. Okay, next one. How have you seen this used at a power plant? I understand that it can find instrument airline leaks, but I'm interested if you have tried it on HRSG penetrations. Also, a leaking valve produces internal ultrasound frequencies. Is this able to pick up internal leaks? I'd be interested in a demo, like for a day at the power plant. So this is one specific customer asked a couple questions. But.
Yeah, I haven't actually tested that. Once again, I recommend that you get a demo and try it. As far as internal leaks, it depends on how large the leak is. You usually like to have direct line of sight when you can. That's going to give your strongest signal. You're not going to be able to specifically see through panel doors and things like that. But if there's any kind of vents or things, in the way, you can see it'll diffuse around the vents or reflect back and forth in a cavity and come out. We've had some pretty good results with a large aircraft manufacturer finding air leaks and line leaks behind panels. All right, but these are not like solid steel panels or anything like that. So it's really going to depend on the situation. Try it out. I mean, definitely let us know. We'd love to see the results. As far as the ultrasonic frequencies, though, I mean, you're able to get from an ultrasonic standpoint, you're able to see from 20 kilohertz all the way up to 52 kilohertz. And that's far more than traditional airborne ultrasonic tools. Typically, if you're trying to look inside of something, you want to use contact ultrasonics, and this is not contact. This is airborne. airborne sonic, airborne ultrasonic.
Okay, same gentleman. He said, what about a duct leak at a coal plant that is insulated? Is that possible? Maybe it would redirect the signal out to an opening?
It is possible. It's possible. I guess it depends on how thick is the insulation, how loud is the rest of the noise that's around the area, and how big's the leak. It's all about, you know, the leak frequency and the leak loudness is all about the nature of the leak and usually how much flow is coming out of that leak. If it's a really low flow leak, you're going to have less chance of seeing it through insulation. If it's a really high flow leak, you're going to have a better chance. Sound finds a way out.
Okay, next question. Can you find natural gas leaks at low pressure, for example, 7 inches of water column to 11 inches of water column?
So I'm not real good at the water column calculations. I'll tell you that I have detected higher flow air leaks at 4 psi from 10, 20 feet away. Very small air leaks, you know, relatively speaking. And I've also detected very low flow air leaks at a rate of about 10 cc per minute, 10 cubic centimeters per minute, at about 90 to 100 psi back pressure and atmospheric pressure of, you know, standard temperature pressure of 14. So it's possible. It's going to depend on your situation.
Okay. So there's a lot
now, just to be clear on this, this is not a product to replace sniffers, and it's also not a product that, you know, if you've got a facility or a plant or a process that uses helium sniffers. This is not a parts per million type of detection. This is more of a gross leak detection.
Okay. Have you tried testing the equipment to detect corona discharge on feed?
Well, we've done some research on it, and we're continuing to do research. I won't say that it will or won't specifically yet, but we're looking at it, and the results are pretty promising so far. But we've noticed that there are some different things that are needed by some customers that need corona discharge type of inspection versus air leaks. This particular product, the I-900, has been optimized for air leak inspection or gas leak or vacuum leak inspection. And we're continuing to work on sensitivity. We're continuing to work on how do we need to modify the technology to detect other kinds of sounds.
Okay. How far away can you be and still detect a leak?
Once again, it depends on how loud the leak is. I've detected some pretty significant leaks at manufacturing companies in the middle of production from 150 feet away. You know, way up on the ceiling and the rafters, I'm able to see a hose leak, you know, air leak on a hose reel or a connection or something like that, and I'm way down on the production floor. So the smaller the leak, the closer you typically need to be to it. The bigger the leak, sometimes you can see it from a good distance away.
Okay. What's the battery life on the unit?
We've been sealing in right now in about 6 hours officially, but that's always on with high brightness. We actually have been, you know, empirically from me doing inspections, I've seen it last a full day of inspections, to be honest with you. And you get 2 batteries with it too. So there's no reason why you can't get a full day's worth of work out of this and not even worry about it.
Great. What about how many images can you store?
I think we're just shy of 1,000 images right now. You know, just like with our infrared cameras, though, we don't recommend that you keep all of your images on the unit when you're not using it. We recommend do a day's worth of inspection or whatever your normal route is. take them and download them to a PC where they're a little bit more safe, because you never know what happens to the memory that's inside of our electronic devices. It's a kind of memory that can be affected by really strong EM fields and things like that, and it's best just not to take the chance.
Okay, well, that looks like that's it for our questions today. And that concludes our time for the webinar. If you have further questions that went unanswered or would like to find out more about what Transcat offerings are as far as product or service, you can contact us at 800-800-5001 or on the web at transcat.com. You can also email me directly at nvanword@transcat.com. Thanks for joining us today. We hope you got something out of the presentation and that you continue to join us for future Transcat e-learning webinars. Thanks to the Fluke team as well. Thank you.
Thank you.
Thanks, Nicole.